Hi everyone. In this movie, I'm going to show you how to assemble a light curve from several sessions of data about an asteroid. So you can see here that I have a preliminary light curve of 4880 Tov-Stanagov. So this is a light curve that has been generated from a single session worth of information. I'm going to click on the sessions form here just to show you that I have more sessions related to this particular asteroid, session 213, 214, 215, and I have one later on. There it is, session 222. So 4 sessions in all on this particular asteroid. I'm going to make sure I have this asteroid clicked and say OK. I'm going to get out of the sessions form. And now I want to show you how to add in those other nights. So when I click the Find button here and I have several sessions in the sessions form, like I just showed you, I'll have all of those represented here in the sessions form. So all I need to do is just select the sessions. I'm going to highlight all of them and push OK. And there it is. The Composite form and the period analysis form are going to be really useful in a few minutes, but I don't want to really focus on those right now, so I'm going to move them off to the side. So you can see that the plot doesn't look particularly pleasing. We have these bands in certain regions, but we don't have anything that really looks like the light curve we expect. That's because this is a raw plot, meaning that the brightness of the asteroid is plotted as a function of time, and because we measured the brightness over the period of several days, it has just put that data in where appropriate, but it hasn't overlapped it. So in order to get the curve to be folded, I'm going to unclick the raw button up here, and I'm going to click the Fourier analysis button. And now I'm going to ask the Canopus program to do the same job again. Before I do that, I need to tell it over what range of periods I want it to search. So I'm going to have it start with a period of 2 hours. Not too many asteroids have rotation periods shorter than 2 hours, although some do, but it's a pretty safe thing to choose 2 hours to start. And then I'm going to have it look in step sizes of 0.1 hour over 100 steps. So it's going to check 2 hours, then 2.1, then 2.2, then 2.3. And 0.1 times 100 gives me 10. So it's going to go from 2 hours all the way up to 12 hours looking for possible periods for this asteroid. So let me go ahead and do it. I'm going to push the Find button again, keep all of these sessions highlighted, OK, and there it is. It has done the best job it can to overlap this data. If we go to the period search results, or the period spectrum, we can see that it found decent matches at a period of a little less than 3 hours, something between 5 and 6 hours. That's what it's given us here, 5.4. And another one out here at a little better than 8 hours, and another here at a little more than 10 hours. And as we've discussed before, the bimodal solution, which it is showing us here, is most likely the right period. So it looks like we have the right period. And you will also get dips in the period spectrum at twice the correct period. That's up here. At 3/2 the correct period. That's here. And also at 1/2 the correct period, which is over here. So it looks like we're doing well, and we actually have the right period here. Now, one of the things you can do is you can adjust the data a little bit so that it overlaps a little bit better. You can see that the green and the purple data is overlapping really nicely, but these blue boxes look like they're generally all a little bit too low. So the blue boxes are from session 222, and this comp adjust form allows you to just shift all of those around slightly. So I'm going to highlight 222, and I'm just going to click this arrow to move those blue boxes up a little bit. And when I push replot, watch the graph here, you can see that those blue dots go up. And I think that's probably about enough. Maybe you'd want to click one more. You sort of want to use this sparingly because you can get yourself into trouble if you use the comp adjust form too liberally. So in general, it's great if you can keep the comp adjust to be less than 0.1. And typically it will be even smaller than that. But as I say, just be careful with it. It looks like these blue crosses from session 213 could also use a little bump. Let me bump those up. Yeah, maybe a little bit more. This looks pretty good. So now that I have a light curve that's looking pretty nice, I can refine it a little bit. I only found this period to the nearest tenth of an hour. Let's see if we can do better. So what I'm going to do, now that I know the period is between 5 and 6, I'm going to go up here and start at 5. And I'm going to now search in much smaller intervals. Let me go by 1/1000th of an hour. And I'm going to range from 5 to 6 hours. So I'm going to put in 1000 here as my number of steps. And now when I push find and OK, it looks like the curve has snapped together a little bit better now. And I have an uncertainty out to 1/1000th of an hour, which is very nice. And so the light curve is looking pretty good. There's one more thing that you can do. By changing the number of orders, you can affect how curvy your graph is. So if you just have 2 orders, the graph will be something very close to a sine wave. And it won't necessarily fit the data particularly well. If I go up to 4, I think you'll be able to see how the curve is kind of not quite so sinusoidal now. And if I go all the way out to something like 10 orders, which is probably not a great thing to do, but just to show you, then you can see now the curve is getting very wiggly. Why is that not a great thing to do? Well, probably part of the wiggly nature of the black curve is just due to random scatter in my data. And so realistically, there might be the curve might not be quite sinusoidal, but it's probably not as curvy as this shows. So let me go back to 4 orders. I think that's probably pretty reasonable. And there it is. So it's a pretty nice looking curve. There's a little bit of scatter in it, but there can be no doubt that we have a bimodal solution, and it's looking very much like 5.4 hours is the right solution. So when we go back to the period spectrum, you can see there is some variation, and it's kind of fun to go and check to see, like, what would this look like? Would this be a reasonable solution? I mean, it's not quite as deep on the period spectrum as this one is, but maybe this would be a reasonable thing. Well, you can always do that. You can see that this solution is between 5.1 and 5.2. So how about just going up here, change this to 5.1, and instead of going by steps, by 1,000 steps, let's just go through 100 steps, and then we'll be guaranteed to see what the curve looks like when we force the solution to be 5.1 something hours. So I'll just do that. And you can see, okay, so it's not a bad solution. It's bimodal, and there's some curviness there. But it pretty clearly is not as good as the previous solution that we had. So anyway, this just gives you a sense. It's not a bad idea to look at some of the other solutions just to convince yourself that you've really got the right thing happening here. But I think that we do have the right solution. So now that you've got a beautiful picture, you can get rid of these windows for a minute. Maybe you want to actually save this picture. You might take a screenshot, but the more robust way to get this curve is to go to this little book icon, and save LC plot is save light curve plot. So I'll click on that button, and I'm just going to save this one to my desktop, and I'm going to use the default 4880 Tog Stanagov. I'm going to push save, and it should be there. So I'm going to minimize MPO Canopus here and see if I can find what I just saved. There it is. Now if I double click this, it should come up, and there it is, 4880 Togstanagov.